Hi guys, myself Shaheed-Ul will be presenting the video lecture session today powered by leading institution platform. I will discuss a sample NEET mock physics paper of test series conducted by platform. And second video solution on NEET mock paper will be simplified here today. Students may find this paper little bit difficult, but I will do my best to make you confident attempting problems. Dear student, if you want to enter into the arena of this medical entrance, make sure yourself you can sacrifice anything to reach the goal. Great achievement always requires great sacrifice. The only questions to ask yourself is how much you are willing to sacrifice to achieve success. Success is a simple measurement of commitment, sacrifice, pain one endures to achieve a dream. Most of us don't want success as much we want to sleep. So stay tuned with us and watch video series to develop your strength. Strength and growth come only through the continuous effort and struggle. Strategy without process is little more than a wish list. I strongly believe that sacrifice, struggle and strategy, all these things will fulfill your dreams. This is the fund of success. Otherwise, no other shortcut way to get the success. Please subscribe the channel and join with us. I will also urge you to all my students to share the link to your friends who need it. If you want to join our NEET 21 mock test series at free of cost, you feel free to contact platform for pen and paper mock test series along with doubt clearing session. Hope that these videos will enhance your ability to problem solving attitude and you find the quicker approach here. Now I will start this journey with the first questions on the board. Question number 1. A body of mass 2.9 kg is suspended from a string of length 2.5 meter and is at rest. A bullet of mass 100 gram strikes the block horizontally with velocity 150 meter per second and sticks to it. What is the maximum angle made by the string with the vertical after the impact? So this problem is based on the collision. Here, as per the problem, a body, let us say of mass capital M, is suspended by the wire, and the mass of the bullet, let us say it is M, strikes the suspended body at speed u, and after the collision, if I say the velocity is v, so from conservation of momentum, we can write here mu m plus m into v. So velocity after collision, it is m by m plus m into u. Kinetic energy after collision of the system, kinetic energy, we can write half m plus m into v square, and after putting the value of v, we can write it is m square by m plus m into u square. And because of this kinetic energy, body will ascend up to a certain height, making an angle theta with the vertical line. If this height ascend by the body, if it is taken h, then we can say from conservation of energy, mgh equal to half m square by m plus m into u square. And this height can be written in this way. We know if a body is thrown upward with the speed u, then the maximum height attained is equal to u square by 2g. If a body ascends with the velocity u vertically up, then the maximum height attained is equal to u square by 2g. But in this case, it is u square by 2g. We can write here the total mass is equal to m plus m. So the height in this case, it is m by m plus m whole square. So in this equation, in the height ascending, two part in this problem. One part is u square by 2g. It is actually height ascent by the body when it is thrown up at a speed u. But in the case when body strikes with the hanging body and it strikes and sticks to it and ascend up to height h, then the height ascending here h is equal to u squared by 2g into m by m plus m whole square. I must say here, you can keep this equation for any competitive examination for this type of problem. In the examination hall, it will take time less, or with the least investment of time, we can solve this problem if we start from this equation. So the height attained is equal to u square by 2g m plus m by m plus m whole square. And you know, h is equal to, actually from the diagram, total length of the string is L, and the angle subtended by the string with the vertical line is theta. So it is h is equal to L minus L cos theta, and this is u square by 2g m by m plus m whole square. So 1 minus cos theta equal to, we can write u square by 2g L m plus m whole square. You know, this is 150 whole square by 2 into g. By default, I have to take here the value of g is 10, and the length of the string is 2.5, mass 0.1 by 3 whole square. And by simple calculation, if we calculate this numericals, it is actually becomes half. So cos theta is equal to half, and by this way theta is equal to 60 degree, and the right option here matches with 3. Let us move the next problem of this video session. The electric field of a plane electromagnetic wave varies with the time of amplitude 2 volt per meter, propagating alongside the average energy density of magnetic field. In the electromagnetic wave, energy average associated with the magnetic field is equal to 1 by 4 b square by mu naught. And we know speed of light equal to c root over epsilon naught mu naught, and it is also E naught by B naught. E naught means the peak value of electric field and B naught is the peak value of the magnetic field in the electromagnetic wave, where electric field and magnetic field oscillating mutually perpendicular to each other. Okay, and by simple calculation E average we can write 1 by 4 B naught is equal to E naught by C square into mu naught and 1 by 4 it is E naught by, if we put the value of C naught, then it is mu naught 1 by epsilon naught mu naught, and finally it is 1 by 4 E naught square. Finally this becomes epsilon naught E naught square, and it is 1 by 4. The value of epsilon 0 8.86 10 to the power minus 12, and the amplitude electric field it is 2 square, and very simple, it is 8.86 into 10 to the power minus 12 joule per meter cube. Right option matches with 2. Moving on the next problem, question number 3. A parallel plate air capacitor has capacitance C. When it is half filled with the dielectric constant 5, the percentage increase in the capacitance will be. We know capacitance of this condenser C equal to epsilon A by D, but when this capacitance is filled with dielectric, then we can say K equal to K into A1, A2, the area is A1 and area of this portion is A2, then we can say the equivalent dielectric constant is Ka into A1 plus A2 equal to K1 A1 plus K2 A2. So K is equal to K equal to dielectric constant 5, it is K into 2A, let us say it is 5 into A, and it is 1 into A, dielectric constant of air is 1. So here K equal to 3, equivalent dielectric constant is equal to 3. So capacitance, new capacitance in this problem, we know K epsilon naught A by D, and this is 3 epsilon naught A by D. So the capacitance is 3 times the capacitance with the 3 times the capacitance previous, that is dielectric air, and the change in capacitance equal to C prime minus C, this is 2C. This means the percentage increase of the capacitance is 200%. because you know the change in the capacitance is 2 times the previous capacitance. So the percentage change here is 200%. So right option here matches with 4. Next problem. The electric potential at a point as a function of distance in meter is given by V equal to 5x square plus 10x minus 9 volt. So it is the equation given, this is the equation of potential given in the problem, and it is varies with the x. We have to find out electric field here. Electric field from the definitions, we know negative gradient of potential difference, and this is, we can write ddx, it is 5x square 10x minus 9, and finally this is minus 10x plus 10, and we have to find out the electric field at the point x is equal to 1. So electric field is equal to 10 plus 10, this is minus 20 volt per meter. Right option here is 1. Next problem. Question number 5. If a photocell is illuminated with radiation 1240 Armstrong, the stopping potential is found to be 8 volt. Then the work function of the emitter and threshold wavelength are. First of all, we have to find out here energy of photon. Energy of photon E equal to h nu by lambda, and putting the value of Planck constant it is AC by lambda. Putting the value of speed of light and Planck constant, we can get here the equation is 12,400 by wavelength in Armstrong, and it is electron volt. So energy 12,400 by 1240. So energy of photon incident on the metal surface is 10 eV. Stopping potential, we know Einstein's equation, maximum kinetic energy h nu minus work function. Stopping potential is the minimum negative potential of anode with respect to cathode to stop the electrons of maximum kinetic energy. It is EVS equal to h nu minus work function. So from this equation, work function equal to h nu minus EVS, and the energy of photon incident upon the metal surface of the given metal surface given in the problem, it is already calculated 10 eV, and stopping potential it is volt, that is 8 eV, and the work function it is 2 eV. So by this calculation, up to the work function, the option 4 can be discarded only. Let us check the threshold wavelength. What is the threshold wavelength? Threshold wavelength here Again we can say lambda AC by lambda max equal to work function, that is the maximum wavelength of the incident photon to eject the electrons is lambda max, and lambda max is equal to, we can write AC by work function. And again by putting all these you have to use in the examination hall, it is 12,400 by work function in EV and the wavelength in Armstrong. So we can write 12,400 by 2 and the answer becomes 6200 Armstrong. So right option here is 2. Next problem. In the circuit shown below, the cell E1 and E2 have the EMF 4 volt and 8 volt and internal resistance are given 0.5 ohm and 1 ohm respectively. The potential difference across E1, E2 will be, here the cell is E1 and the cell is E2. First of all we have to find out the electric current. So circuit current since the potential EMF of the cell 2 is greater than the EMF of the cell 1, so finally the circuit current will be in this direction, it is I. So circuit current I equal to E2 minus E1 by external resistance R plus equivalent internal resistance. Since these two cells are in opposite polarity and E2 having the greater potential, so I have written here E2 minus E1, it is 8 minus 4 external resistance. First of all, external resistance we have to find out here, equivalent external resistance. Equivalent external resistance 6 into 3 by 6 plus 3 plus 4.5, so this is 2 plus 4.5 and it is 6.5 ohm. So 6.5 ohm plus internal equivalent internal resistance is 1.5, 4 by 8, and the circuit current is half ampere. We have to find out the potential difference. Cell 1, it is in charging condition. When it is in charging condition, when current internally from positive plate to negative plate, this means this cell is charging, and cell 2, current delivered by this cell from current flowing in this cell is internally negative to positive plate, or you can say externally current delivered by this cell externally from positive plate to negative plate. But here current flowing from negative plate to positive plate, when current flowing negative plate to positive plate, then this cell is charging, and current flowing from positive plate to negative plate, so this cell is discharging. In the case of charging, potential difference is equal to V1 equal to E1 plus IR1. Here E1 is equal to 4 volt and current equal to half ampere, and the resistance is also given there is half ohm, and finally the potential difference is 4.25 volt. by checking one potential difference across the cell 1, we can discard the option 1 and 3. So out of these 4 given, 4.25 and 4.25, and other option is 4.25 7.5 volt, and in the case of cell 2, it is discharging. So potential difference, in the case of discharging, potential difference is equal to EMF E2 minus IR2. It is given 8 volt, current is half ampere, and the internal resistance is 1. So this is 7.5 volt. So the potential difference across the cell 1 is 4.25 volt, and potential difference across the cell 2 is 7.5 volt. The right option here is 2. Next problem of this session. The spherical shape of raindrop is due to, it is surface tension. Simple questions, theoretical based question. Because of the surface tensions, the surface area of any liquid drop try to minimize its surface area so that it can possess the minimum potential energy. Okay, next problem. So number 8, find the ratio of specific heat at constant pressure to specific heat at constant volume for NH3. So gas exponent gamma equal to Cp by Cv, molar specific heat at constant pressure by molar specific heat at constant volume, and it is equal to 1 plus 2 by F. Here F is the degree of freedom. Monoatomic gas degree of freedom is 3, and the value of gamma equal to 5 by 3, and it is 1.67. If we take diatomic gas, in the case of diatomic gas, degree of freedom is 5 and value of gamma equal to 7 by 5, and it is 1.4. And triatomic gas, degree of freedom is equal to 6. It is non-linear orientation, and the value of gamma is equal to 4 by 3, so this is 1.33. Here, with the rise of atomicity, the value of gas exponent gamma decreases. So this is decreasing order. In the problem, it is given NH3. NH3, it is actually polyatomic gas. So gamma should be less than 1.33, because with rise of atomicity, the value of gas exponent gamma goes on decreasing. The value of gamma should be less than 1.33, because in the case of diatomic gas it is 1.33, and in the case of polyatomic gas, that is more than 3 atoms in a molecule, the value of gamma should be less than 1.33, and the right option here is 3. Next problem. Question number 9. Two metal strips that constitute a thermostat must necessarily differ in their coefficient of linear expansion. 1, 2, 3 are not the right option. Thermostats actually two type of metal. Two type of metal. Bar is used of equal length having different coefficient of linear expansion. Since these two bar attached at both ends, pivoted at both ends, having the different coefficient of linear expansion because of the heating, or due to heating, this different the length of these two bar will be different, and because of that it will get a shape of arc, and this can be used as a thermostat. So right option here is coefficient of linear expansion. Next problem. Question number 10. The mass of moon is about 1.2% of the mass of the earth. Compared to gravitational force the earth exert on the moon, the gravitational force on the moon exert on the earth, whatever may be the mass, you know, here the gravitational attraction on earth by moon, or gravitational attraction on the moon by earth, and this is mutual attraction to each other. We can write here force on E by m and force on moon by earth. It is mutual attraction and equal to each other, so is the same, is the right option here. Question number 11. The frequency of sound wave is n and velocity is v. If the frequency increase to 4n, the velocity of the wave will be, so wave velocity does not depend on frequency. It depends upon elasticity and inertia of medium through which sound wave propagating. As per, you know, Sir Isaac Newton equation, velocity of longitudinal wave equal to root over of coefficient of elasticity by density of the medium. So doesn't matter what is the frequency of the wave. If the frequency is increased, then the wavelength of the wave is decreased. Henceforth, the product of the frequency and wavelength remain constant. So right option here is 1. The mass of a box is 2.3 kg. Two marbles of masses 2.15 gram and 12.39 gram are added to it. So the total mass it is 2.3 kg and it is 0.00215 kg plus 0.01239 kg, and after adding this 2.314 kg roughly, so 2.31 kg. Since the least significant digit in the case of addition, it is here in this figure, the least significant digits here least significant digit is 2. So answer will be in the form of least significant digit in the case of addition or subtraction. So answer is 2.3 kg. Right option here is 3. Next problem. An automobile engine develops 100 kilowatt when rotating at a speed of 1800 revolution per minute. What torque does it deliver? It is actually question based on power. Power equal to, we can write tau into theta. This power is constant power, tau into omega. We have to find out here torque, that is P by omega. Power given in this problem 100 kilowatt, 100 into 10 to the power 3 by revolution given here per minute, 2 pi f, and this is 100 into 10 to the power 3, 2 pi into 1800 by 60, that is revolution per second. And after simple calculation, this becomes near about equal to 531 Newton meter, and the right option 3. Next problem, question number 14. The acceleration of particle performing SHM in 12 centimeter per second square at a distance 3 semi from the mean positions is time period each. So acceleration of simple harmonic motion, acceleration of particle executing simple harmonic motion A equal to omega square x. I have written only the magnitude of the acceleration, and it is omega square is equal to A by x. We can find root over of A by x. A given in this problem is 12 and the x given in this problem is 3 centimeters, so it is 2 rad per second. We have to find out here the time period of the oscillations. So t is equal to twice pi by omega, and this is twice pi by 2, and finally the answer becomes pi seconds, and the right option here is 4. Next problem of this session, number 15. 4 bodies P, Q, R, S are projected with equal velocities having angles of projection 15 degree, 30 degree, 45 degree and 60 degree with the horizontal respectively. The body having the shortest range. We know range is maximum when angle of projection with horizontal is 45 degree and range is minimum for that angle which is farthest from 45 degree. Here 15 degree is the farthest from 45 degrees, so the right option here is 15 degree is corresponds to P, so the right option here is 1. Let us see what is the next question. Here the acceleration time graph of the body is shown below. Here acceleration A by T equal to tan theta, and let us say it is K, I mean it is constant. So acceleration equal to KT. Here acceleration is proportional to time. Difference, we can write rate of change of velocity equal to KT. So dv equal to KT dt, and on integration we can write half KT square. So v varies as t square, and the nature of this is parabolic. But after some time, as per the graph given, the acceleration becomes 0. When acceleration becomes 0, that means the velocity v is constant. Option 1 is not the right option here, because here the change with the velocity time is linear. Option 2, velocity and time, it has the parabolic nature, but this is not correct option. Option 4, it is linear nature, velocity versus time, so 4 is also not the right option. Here the option 3, it is parabolic nature and the velocity increasing, and after that, after some time, when acceleration becomes 0, the velocity of the particle becomes constant. So therefore the 3 option is correct option. Next problem of this video session: two wires A and B have the same length area cross section, but the Young modulus of A is 2 times the Young modulus of B. Then the ratio of the force constants. You know, Young modulus it is A by A, X by L. Here X is the expansion I have taken, expansion of string. So A equal to AY by L into X, and this is KX. Here K is known as AY. K is equal to AY by L, and this is known as, it is force constant. So force constant for the material A by force constant for the material B, same length and area of the cross section, so it is actually YA by YB. That is Young modulus of the material A and Young modulus of the material B. Here the Young modulus of A is twice times the Young modulus of B. We can write here it is 2. The right option here is also 2 and 2. Let us see question number 18. A body is just floating on the surface of liquid. The density of the body is same as that of the liquid. The body is slightly pushed down. A body is just floating, that is body is just floating means body floating completely immersed. Body floating completely immersed. Body is just floating means here body is floating completely immersed. In this case, the buoyancy that acts upward and the weight of the body downward and the net force on the body equal to mg minus b. Since it is floating completely immersed, it means buoyancy equal to mg and the net force on the body equal to 0. So if it is slightly disturbed or slightly pushed down, so what happened? It will move down with a uniform velocity. Since the net force on the body is 0, so it can move without acceleration, freely move inside the liquid. So right option here, it will slowly come back to its earlier positions. This is not correct option. It will remain submerged where it is left. It is also wrong. And it will sink, it will come out of violently. It will sink, and 4, it will come out violently. It is not also true. When buoyancy is greater than the weight of the body will come out violently at some velocity. Okay, next problem. A person sitting an open car moving at constant velocity throws a ball vertically up into air. So horizontal component of velocity of ball and of car horizontal component of velocities of ball and of car are equal. So car and ball will move with the same horizontal range. Since the ball inside the car in the same frame, so the ball fall outside the car, it is wrong answer. In the car ahead of the person, it is also wrong answer. In the car to the side of the person, it is not also true. Exactly in the hand which threw it up, 4 is the right option here. This problem based on the conception, no calculation is required. Since the ball, when it is thrown up, having the velocity, what is the velocity? Car moving, the ball will attain the same horizontal velocity. What is the velocity at the velocity of car? So both the body, that is ball and car, move same horizontal displacement. So this is why ball exactly come back exactly in the hand which threw it up. So 4 is the right option here. 20. An insect crawl up a hemispherical surface slowly. It is a hemispherical surface. Let us say an insect and this angle given in the problem is theta. Here important fundamental, a body placed on inclined plane, a body is placed on inclined plane, or body will remain stationary kept on the inclined plane up to the angle that is angle of friction. It is also known as angle of repose, and this angle of repose is equal to the angle of friction. And tan lambda we know equal to mu. If lambda is the angle of friction, we can say tan lambda is equal to mu. Mu is the coefficient of friction. So angle of repose is the maximum angle of inclination up to which a body can remain stationary on the inclined plane. If we draw a tangent at a point up to which an insect crawl up, we get a inclined plane, that is hemispherical bowl. If we draw the tangent at different point, we get the different inclined plane of different inclinations. That is, we can say this is variable inclination. But at a particular point, when the inclination of the inclined plane just becomes equal to phi, that is equal to angle of friction, up to this angle the insect can stay stationary without falling down, and it is tan lambda is equal to mu if we connect the conception with the body placed on the inclined plane. Here cot lambda is equal to, we can write it is mu, and mu given in the problem is 1/3, so this is 3. So only one right option here is cot alpha equal to 3. 2, 3, 4 are the wrong answers. Next problem. Question number 21. A particular mass M moving with velocity at speed 6 meter per second collides elastically with a particular mass M at 4 meter per second. So this is the problem based on the elastic collision. You know, for the elastic collision, velocity after collision is elastic, so velocity v1 equal to m1 minus m2. You have to use, we have to use this formula as a reference formula. Directly you have to apply this formula. You have to write this formula in the examination hall. You have not the enough time to deduce this formula. So m1 minus m2 by m1 plus m2 u1 2m2 u2 by m1 plus m2. And in the problem, I have taken m1 is equal to m and m2 equal to capital M. It is a heavier body, and m is less than m. So the mass of the lighter body can be neglected. It is neglected, so therefore we can write here v1 is equal to minus m by m into u1 plus 2m by m into u2. Finally the equation becomes minus u plus 2u2, and u1 given in the problem, you know, minus 6, and it is given in the problem it is 4 meter per second into 4, and this is 2 meter per second. So 1 is the right option here. 2 meter per second in the original direction. Next problem. A watch shows time as 3:25 o'clock. When seen through a mirror, time appear will be. In this case, if we seen through was source time 3.25 o'clock, 2.25 o'clock seen through a mirror, so actual time it is 11.60 minus 3.25, and this is 8.35. So in such type of problem you have to use this, you have to use this formula, you have to use this fundamental actual time. You have actual time from 11.60 minus 3.25 given in the which is seen through the mirror. So actual time here is 8.35. Two object A and B when placed one after another in front of a concave mirror of focal length. Here the mirror given is concave mirror. Concave mirror, and nature of the concave mirror is converging. Focal length of the mirror given is 10 centimeter. An object is placed outside the focus. The image formed is also real. Here the object is real, image is also real, and nature of the mirror is converging. So code of this problem is RRC. It is already I have discussed in my theoretical class on ray optics. And from the Newtonian concept, if the distance of the object from focus is x and distance of the image from the focus, this is image, is y. If it is taken y and if it is taken x, then the linear magnification Sir Isaac Newton's equation, as per the Sir Isaac Newton's equation, linear magnification we can write is equal to a by x, and a is equal to, it is u minus f. So very simple. If we use this code, and for this code, when object is placed outside the focus and the object distance taken from the focus from the Newtonian concept, and from Newtonian concept we can write the linear magnification, that is Newton's equation. Linear magnification m is equal to f by x and equal to f by u minus f. Simple. This is linear magnification as per the Newtonian concept. Okay. And this problem can be solved very easily, though it is very difficult problem, difficult type of problem for the students, particularly in the examination hall. Here magnification linear magnification for object A by linear magnification object B. We can write it is actually xb by xa, because you know already I have told as per the Newtonian equation magnification equal to f by x, and it is IA by OA, and it is OB by OB by IB, that is the size of image for the object B. OB is the size of object of V, and you know we can write it is UB minus F and it is UA minus F. Size of image of A and B both are equal to each other. Size of image both are equal to each other. Size of object OA is 4 times. Size of object A is 4 times the size of object B. So it is 1 by 4, and UV minus 10, focal length given in the problem is 10 centimeter, and UA given 50 centimeters. So this is 50 minus 10, and by simple calculation UB minus 10 is equal to 40 by 4 and UB equal to 10 plus 10, this is 20 centimeters. So this problem becomes so simple, and the answer is correct option matches with 2. Next problem. A telescope has an objective lens of 10 centimeter diameter situated at a distance 1 kilometer from two objects. Two objects placed at a distance from the objective lens. Let us say this separation is D and this distance is S, and the limit of resolution theta is equal to 1.22 lambda by A, where A is the slit aperture, and this theta can be replaced by D by S. It is 1.22 lambda by A. D is the minimum separation between two close objects, so we can resolve the two objects from 1 kilometer by this telescope. So D is the minimum separation, 1.22 lambda into S by A, and putting this value 1.22 lambda given in this problem 5000 into 10 to the power minus 10 meter into S means 1000 kilometer, 1000 meter, 1 kilometer means 1000 meter, and aperture given is 10 centimeters, so that is it is 0.1, and it is 6.1 approximately 10 to the power minus 3 meter, and we can write 6.1 mm, and 6.1 mm is the minimum separation required to resolve these two closely placed bodies or points. And here in the option, first option given 0.5, first option given 0.5 meter, this is not right, this is not 5 meter, this is not in the range of meter, this is not centimeter, it is also not in the range of the minimum separation. So only 3 can be the correct option, though it is not numerically, 5 mm is not numerically found here, but it is in the range of the mm. So 3 is the most correct answer here. Next problem. Two interfering waves having intensities are 9I and 4I. Path difference between them is 11 lambda. The resultant intensity at this point will be, we know phase difference phi is equal to twice pi by lambda into path difference. So So twice pi by lambda into path difference given in the problem is 11 lambda. 11 lambda. So this is 22 pi. This is even multiple of 2 pi. Even multiple of 2 pi. It means it is same phase. If the phase difference is the even multiple of 2 pi, we can say the two waves meet at a point of the same phase. Okay. And you know the maximum intensity, we have the ready-made formula you have to use. It is root over I1 plus root over I2 whole square, and in the problem it is given 9I and it is 4I whole square. I can write this is 3 it is 5 root I whole square, and finally this is 25I, and the correct option is 4. Next problem. A diffraction pattern is obtained using beam of red light. What happens if the red light is replaced by blue light? There is no question is asked here, so we have to go through the option given. No change. This is not right. Diffraction bands become narrower and crowded together. Bands become broader and further apart. Bands disappear. This is also not true. You know, in the case of bandwidth, central fringe width, central fringe width 2 lambda d by A is the aperture of linear slit, and D is the distance, capital D is the distance of the screen from the single slit. Red light is replaced by blue light. Wavelength of blue light is less than the wavelength of red light, as it is given in the problem. So diffraction bands become narrower and crowded together. 2 is the right option here, 3 is not the correct option. Next problem of this session. Heavy nucleus at rest breaks into 2 fragments with fly off with the velocities in the ratio 8:1, the ratio of the radius of the fragments. So this is the problem based on the explosion into 2 particles. Explosion into 2 particles. After explosion, let us say one particle moves along this direction v1, another particle moves along left direction at speed v2. Before explosion, the momentum of the body is 0. So after explosion, their momentum must be equal and opposite to each other. Therefore, their vector sum of the momenta of the both the particle becomes 0 as per the conservation of momentum. If the momentum of this particle is P1 and the momentum of the particle is P2, then we can say P1 plus P2 should be equal to the momentum B4, and this is 0. So this is why you can say momentum of the particle 1 is equal to momentum of the particle 2. It is very important in the case of the explosion into two particles. So from the conservation of momentum, before explosion the momentum is 0, after explosion the momentum must be 0 as per the conservation of momentum, since there is no external force applied there is no external force applied for this collision, for this explosion. Since there is no external force is applied, the total momentum, the momentum remain constant. So before after the momentum remains same. So momentum of the particle 1 and momentum of the particle 2 are equal in magnitude. We can write here m1 by m2 is equal to v2 by v1. But we have to find out here the radius. So we can assume that in this case, in this explosion, that two particles also having the circular shape or spherical shape. Since the ratio of the radii of the fragments is asked here, therefore we can write it is r1 by r2 q equal to v2 by v1. r1 by r2, it is actually v2 by v1 to the power 1/3. Let us see what is the velocity given in the problem. The ratio of the velocity, breaks into fragments fly with the velocities in the ratio 8:1. 8:1. So this is 1 by 8, 1/3, and it is 1 by 2. So right option here is 1. Next problem. Question number 28. At any instant, the ratio of the amount of radioactive substance is 2:1. If their half-lives be respectively 12 and 16 hours, then after 2 days, what will be the ratio of the substances? Here the amount is 2x and x. Let us say the amount is 2x, since the initial ratio of the amount of radioactive substance is 2:1. So I have taken here 2x and x, and this amount will be after the 2 days, that is 12 hours is the half-life. So after 2 days, that is 48 hours, 4 half-lives, and this is 2 to the power 4. This is 2x by 16 equal to x by 8, and for the other element the amount is x, and after 2 days half-life is 16 hours, so time 48 hours, half-life is 16 hours, so this is 3 half-lives. So after 3 half-lives the amount of the substance is x by 8. So simply the ratio is 1:1. So right option here is 1. Next problem. Question number 29. 2 photons each of energy 2.5 hours simultaneously incident on a metal surface. If the work function of the metal is 4.5 eV, then from the surface of the metal, there is no question is asked in this problems. So we have to go through the option given 1, 2, 3, 4. Here first I must discuss here energy of photon incident it is 2.5 eV, which is less than the work function. It is actually work function given in the problem. 1 electron absorbs one photon and gets energy (2.5 eV), which is less than 4.5 eV. First option here, 2 electron will be emitted. This is not a right option. Not even a single electron will be emitted. This is the correct option, matches with 2. 1 electron will be emitted, more than 2 electron will be emitted. So these are not the possible, because no photoelectric emission taken place. No photoelectric effect will be taken place. Next problem of this video session: the de Broglie wavelength of an electron having 80 eV of energy, nearly mass of the electron 9.9 into 10 to the power minus 31 kg, Planck constant given 6.6 minus 10 to the power 34 joules second. So the de Broglie wavelength, we know lambda equal to h by p, that is h by root over 2m k. K is the kinetic energy of electron if electron is energized by an electric field of potential difference V, then the kinetic energy of electron we can write here is equal to EV. So the de Broglie wavelength is equal to h by root over of 2m EV, and putting the value of Planck constant, mass of electron and the charge of electron, this value become 12.27 root over of V in volt. It is Armstrong, or this can be written also like this. We can write this equation. It is 150 by V Armstrong. So we have to use this formula to solve this problem, because it is impossible to putting this value, the value of Planck constant, the value of charge and mass of the electron. It is not possible in the examination hall to simplify this calculation. So in this type of problem, my suggestion, you just keep this equation 12.27 root over V Armstrong, or 150 by V Armstrong. So this is the wavelength of an electron. It is for electron, de Broglie wavelength of electron, and the problem becomes very simple if we use this formula. So lambda is equal to 12.27 and the potential given in this problem is 80 eV. It is meant the energy of the electron is 80 eV. It means it is accelerated by the potential 80 volt, and the voltage is 80 volt, and this is 12.27. approximately it is 9, so therefore the answer becomes 1.4 Armstrong. So the right option matches with 4. Next problem. In the following common emitter configuration, an NPN transistor with current gain beta is used, the output of the amplifier will be. Here a NPN transistor is used, and input it is 1 millivolt given in the problem, and the output resistance it is 10 kilo ohm, and input resistance given in this diagram it is 1 kilo ohm. Okay, and we know voltage gain it is actually beta resistance output by resistance input, and voltage it is output voltage. Voltage gain is the output voltage by input voltage, beta into output resistance by input resistance. So we have to find out the output voltage, that is input signal V suffix I into beta into output resistance by input resistance. Input given in this amplifier NPN transistor it is 1 mV, 1 millivolt, that is 10 to the power minus 3 volt, and beta given 100. Output resistance 10 into 10 to the power 3, and input resistance 1 into 10 to the power 3, and finally the output voltage it is 1 volt, and the right option here is 3. Let us see what is the next problem on the board. Question number 32. In oscillating LC circuit, the maximum charge on the capacitor is Q. The charge on the capacitor and energy stored equally distributed electric field and magnetic field. Energy equal to, we can write half Q square by C, it is, let us say, U naught, energy distributed equally between magnetic field and electric field. So we can say the energy equal to U naught by 2, and this can be written as half Q squared by C. So energy associated with electric field or magnetic field, whatever may be the charge on the capacitor at this time, half Q square by C. Let us say the charge on the condenser when the energy distributed equally between electric field and magnetic field, that is in inductor and condenser. And if we say the charge on the condenser is small q, so this can be written as 1 by 4 Q square by C. So it is Q is equal to Q by root 2. So charge on the condenser is Q by root 2 and the maximum charge on the condenser is capital Q. So right option matches with 3. Moving on the next problem of question number 33. 1 mole of gas expands with temperature as V equal to K to the power 2/3. What is the work done when temperature changes by 30 degrees centigrade? Here the equation given in the problem, V equal to K T to the power 2/3. We have to find out the work done here. Work done, you know, work done W equal to integration dW, and this is P dV, and we know PV equal to nRT. So this PV can be replaced, P can be replaced by RT by V into dV. Okay, finally it is RT integration dV by V. So if we take the differential form, taking log both side and differential form, we get here dV by V equal to 2/3 dt by t. And putting the value of dV by V, we can write it is RT integration, it is 2/3 dt by t, and finally 2/3 integration dt, and this is 2/3 into del T. Del T is the change in temperature, and this is given in the problem, it is 30 degrees centigrade. That is the change in Kelvin, it is also 30 Kelvin, and it is R, so the result is 20 R. So correct option matches with 2, and this problem also can be solved by the alternative method, taking the reference equation. If we take the reference equation here, let in polytropic process, the equation P to the power x equal to constant. So the corresponding equation between volume and temperature, T, it is B to the power x minus 1 equal to constant, and the corresponding pressure versus time, it is P to the power 1 minus x T to the power x equal to constant. So these are the standard equation for the polytropic process. We can put the values of x from 0 to any finite value, and in this process molar specific heat C equal to Cv plus R by 1 minus x. Cv can be replaced, you know, R gamma minus 1 and plus R 1 minus x. This part corresponds to change in internal energy, and this part corresponds to change in work done, that is the work done by the gas or on the gas, whatever may be the. Okay, so comparing this equation given in the problem with the reference equation, we can write this equation, you know, V equal to K T to the power 2/3, and it can be written as V T to the power minus 2/3 equal to K, and it is V minus 3 by 2 T equal to K. And comparing this equation with the reference equation t v to the power x minus 1 equal to constant, then we can write immediately after this x minus 1 equal to minus 3 by 2, and the value of x is equal to minus half. So in this alternative way, if we keep this equation as a reference and the standard equation of molar specific heat, so comparing this equation, the equation given in the problem with the reference equation, we have to find out here the value of x, and putting this value we can get the work done del W is equal to R 1 minus x into del T, and this is R, it is 1 plus half into temperature change given in the problem is 30, and finally this becomes 20 R, and the right option here is 20 R, matches with 2. Next problem. So you can use this formula as a ready-made formula, reference formula. So without calculation, this is the traditional way, to find the answer, and it is not sufficient calculation. You just find out the comparing with the reference equation, you just find out the value of x, then we can find the very easily we can find the work done. Okay, next problem. An electron and a proton enter magnetic field perpendicularly. Both have same kinetic energy. Which one of the following is true? So no question is asked is here. We have to go through the option given here. And trajectory of electron is less curved, trajectory of proton is less curved. Both the trajectory equally curved. Both the move on a straight line path. So we have to explain this problem. An electron and proton enter a magnetic field. Since it is charged particle entering into magnetic field perpendicularly, so radius we know q it is mv by q b. Both have the same kinetic energy, and it is the momentum by charge into magnetic field. Momentum can be replaced, it is root 2 mk by q b. Here k is the kinetic energy. K is the kinetic energy. K same charge of the particle, electron and proton, same amount of charge entering into the same magnetic field. So therefore we can write the radius directly proportional to root over of mass of the charged particle, and the ratio of the radius for electron and the radius for proton, we can write it is equal to me by mp, and it is less than 1. So here we can say the radius, orbital radius of electron in the magnetic field is less than the orbital radius of the charged particle proton, and this means the radius of the proton particle is greater than the radius for the electron. radius is greater than the radius of the path orbiting in the magnetic field by proton is greater than the radius of the charged electron in the magnetic field, same magnetic field, it is greater than this. So Rp greater than Rp, radius is more, it means path is less curved. It is very important. If the radius is more, then we can say the path is less curved. Let us analyze the option given in this problem. Trajectory of electron is less curved. No, the trajectory of photon is less curved because radius is more than the radius of electron. So this is not, this is a wrong statement. The trajectory of photon is less curved. 2 is the right option here, and 3, 4 are the wrong answer and automatically discarded. Next problem, question number 35. A proton of mass 1.67 10 to the minus 27 kg and the charge 1.6 10 to the minus 19 C is projected with the speed 2 into 10 to the 6 meter per second at an angle 60 degree to the x-axis, and if the magnetic field of 0.104 Tesla is applied along y-axis. Here along x-axis and magnetic field is along y-axis, charged particle is projected at an angle 60 degree with the x-axis, so the angle with the magnetic field is 30 degree. So this charged particle moves in helical path. Since it is not perpendicular, charged particle is not entering into the magnetic field perpendicularly. It is entering into the magnetic field with some angle with the magnetic field. So first of all, charged particle moves in helical path. As we know, theta is less than 90 or greater than 0. That is the projection, angle of projection of the charged particle into the magnetic field. So in this problem, a circle of radius, it is not correct option, it is not correct option. So either or, the option is 3 or 4 is the right option here. Radius of orbiting charge, it is mv sine 30. Don't write 60 given in the problem. It is actually, it is y-axis, but with the magnetic field, the angle with the magnetic field, the angle is 30 degree by QB, and putting the value, you know, 167 10 to the power 27 velocity 2 into 10 to the power 6, and the value of sine 30 is half, charge 1.6 10 to the power 19, and the magnetic field 104 Tesla, and roughly it is 0.1 meter on simplification. So the right option here, helix of radius 0.1 meters, so right option here is 3. So not necessary to calculate the time period of this problem. If we calculate the time period of this problem, so this problem becomes large, the solution becomes large, and large calculative problem. But in this way, from the basic conception, when charged particle enters with an angle 0 to 90, less than 90, greater than 0, Then the charged particle moves in the magnetic field in helical path. So 1 and 2, immediately applying the conception, the 1 and 2 can be discarded. And if we find the radius of the orbiting charge in helical path, by simple calculation, you have to just add the power, then we get the 0.1 meter, and the right option here is 3. But if we want to write the equation of time period, so my suggestion, frequency is equal to 1 by twice pi into specific charge into magnetic field. This means 1 by twice pi q by m into magnetic field, and time period in this way. We can write this equation time period. My suggestions to keep this equation: frequency, cyclotron frequency of the orbiting charge in magnetic field is always independent of the velocity of the charged particle. It has a value is always 1 by twice pi into specific charge into magnetic field. So time period is the one reciprocal of frequency. So simply this is twice pi m by b, twice pi m by qb, and putting this is twice pi 1.67 10 to the power minus 27 1.6 into 10 to the power minus 19 and 0.014, and this becomes twice pi 10 to the power minus 7 second. Next problem of this video session: water is flowing in a river. If the velocity of layer at a distance 10 cm from the bottom is 30 cm per second, from 10 cm the speed of a layer is 10 cm per second. So viscous dragging force, so you know viscous dragging force is equal to eta a dv dx. dv dx here is the velocity gradient. The velocity of the layer just in contact with the bottom, that is the surface of the river, it is 0. And the velocity of a layer at a height 10 cm from the bottom is 10 cm at a height 10 cm. At a height 10 cm, the velocity is 30 centimeter per second. Okay, so F can be written as eta a, this is v minus 0 by x minus 0. We can write this is eta a v by x, and viscous dragging force depends on the velocity gradient. Definitely depends on the velocity gradient. Eta is the coefficient of viscosity and a is the common contact area between two layers. Okay, here we can say, since this F is fixed, we can say v varieties x. So v2 by v1, it is x2 by x1, 30 by 10, and v2 is equal to 30 into 30 by 10. Sorry, here v varieties x So V2 by V1 equal to X2 by X1, X2 given here in the problem 30 and the 10, you know. So V2 is equal to 3 V1, so this is 90 centimeter per second. Okay. Option 4 is the right option. Next problem. A 100 turn of coil whose resistance is 6 ohm encloses an area of 80 centimeter square. How rapidly should a magnetic field parallel to axis change to induce a current of 1 milliampere in the coil? We know the induced EMF equal to E equal to rate of change of magnetic flux, and it is, you know, ddt equal to AB cos 0, and we can get A dB dt. So the rate of change of magnetic flux required to be changed for getting the required amount of induced current, you know, given in the problem is 1 milliampere. So rate of change of magnetic field is equal to E by A, and this is I into R by A. I in the problem given 1 into 10 to the power minus 3, and the resistance given in the problem is 6 ohm, and 100 turns is here also. 100 turn, number of turns is N, number of turns is N, and number of turns is N. So the 100 into 80 10 to the power minus 4 meter square, and this value becomes 3 by 4 10 to the power minus 3 by 10 to the power minus 1, and it is 3 by 4 into 10 to the power minus 2, 0.0075 Tesla per second. I think the answer is 3. Next problem. In a series resonance LR circuit with source of voltage 50 volt, angular frequency 50 Hz, resistance given R equal to 250 ohm, L equal to 1 Henry, C equal to 20 microfarad. The potential difference across the capacitor. First of all, we have to we can write here in the case of series resonance LCR, this is LCR series resonance circuit. Series resonance circuit. LCR series resonance circuit, that means impedance Z equal to, that is resistance of the circuit. Okay, so from this equation we can write RMS current I equal to, with a source of voltage 50 volt, since it is given V equal to 50 volt, and this volt is equivalent DC voltage, equivalent DC, and equivalent DC voltage actually it can be written as RMS value. Okay, so the RMS current, that is equivalent DC current, we can write it is equal to V by Z, and this is V by R, and V given in the problem is 50, and resistance in this problem it is 250 and 1 by 5 ampere. Okay, so this is the RMS current of the circuit. Here we have to find out the potential difference across the capacitor. So potential difference across capacitor VC equal to I into XC, and it is I by omega C, and this is I by twice pi F into C, and current already calculated 1 by 5 ampere, and twice pi frequency is angular, the source angular frequency given in the problem. So current is 1 by 5 angular frequency 50, and the capacitance 20 into 10 to the power minus 6. Ten to the power minus 10 to the power 3 by 5, and this is 200 volt. Correct option matches with 3. Let's see the next problem. Question number 39. The Brewster angle for the glass air interface is 54.74 degree. If a ray light going from air to glass strikes an angle incidence 45 degree, then angle of refraction is from Brewster from Brewster's law, tan IP is equal to mu. IP is the angle of polarizations. I think the value of tan 54.74 is equal to root 2. So mu is equal to tan IP, that is tan 54.74, and it is root 2. Here we have to find out the angle of incidence. It is the medium, it is air. So mu is equal to sine I by sine R. We have to find out here angle of refraction. So sine R equal to sine I angle of incidence 45 degree, and this value is root 2, and I think it is 1 by 2. Therefore R is equal to 30 degree. Right option here is 2. Next problem. Angle of glass prism is 60 degree and refractive index of the material is 1.414. Then what will be the angle of incidence so that rays should pass symmetrically through the prism? If the prism is placed at the positions of minimum deviation ray passes symmetrically through prism. That means angle of incidence equal to angle of emergence, and R1 equal to R2 equal to R. Say and we know R1 plus R2 equal to A, and from this it is 2R equal to A, and the R equal to A by 2, and this is 60 by 2 given 30 degree. So angle of refraction at the first surface is 30 degree. Now we have to find out the angle of incidence. We have to find out here what will be the angle of incidence. Angle of incidence in this problem, you know, sine I by sine R equal to mu, and in this way sine I equal to mu sine R, and the value of mu given in this problem is equal to 1 by it is given actually root 2, and sine R already we deduced is 30, so root 2 by 2, I think it is 1 by root 2, and the angle of incidence is 45 degree, and the right option matches with 3. Next problem. 2-volt battery is connected across the points A and B shown in figure below, assuming that the resistances of each diode is 0 in forward bias. Here supplied by the battery when its positive terminal connected to A. In this problem, the battery, the point A is connected to positive terminal and B is connected to negative terminal. Diode in the upper branch, diode in the lower branch. Resistance given, it is 10 ohm, and resistance given here also it is 10 ohm. Diode in upper branch is in forward bias, and diode in lower branch is in reverse bias. Because P side of the upper branch connected to higher potential and the N side of the diode connected to the lower potential. So the diode upper branch is in forward bias and diode lower branch is in reverse bias. So diode through the current through this path, this diode does not allow the majority carriers to pass through this. So current through this path is near about 0 or negligible, and current through the upper branch, since it is in forward bias. So simple problem, current through upper branch is equal to V by resistance R plus dynamic resistance of diode, voltage given is 2 and the resistance given is 10. The resistance in forward bias, it is 0 given in the problem. So this is 2 by 10 and the answer is 0.2 ampere. Right option here is 1. Next problem. Two tuning fork have frequency 380 and 384 Hz respectively. They are sounded together, produce 4 bits. Time period of TB equal to 1 by NB. It is 1 by 4 second. Time gap between two consecutive maxima or minima. It is the time gap between two consecutive maxima or minima. But here question is asked, how long will it take to hear the minima after hearing the maximum sound? So time gap between one maxima and minima, t equal to TB by 2 and therefore it is 1 by 8 second. The right option here is 3. Next problem. At what speed should a source of sound move so that observer finds the apparent frequency equal to half of the original frequency? At what speed a source of sound move so that finds the apparent frequency equal to the half of the original frequency? Let us say this is listener and one source is moving away at the velocity vs and the listener velocity of listeners is 0. So the apparent frequency decreases when source moving away from the listener, and the apparent frequency n prime is equal to nv by v plus vs. Okay, or you can use the vectorial formula n prime vectorial formula n prime is equal to nv minus vo dot r cap by v minus vs dot r cap. It is the direction of r cap. It is always taken from source to listener. So you can apply this vectorial formula and it is applicable for any type of problem or any type of cases normally asked in the competitive examinations. N prime, it is n, velocity of sound is v, velocity of listener is 0 and velocity of sound is v. Now we have to find out the angle between Vs and R cap. Angle between Vs and R cap. Angle between Vs and R cap is 180. So cos 180, it is Vs 1 cos 180. And finally the formula becomes Nv by V plus Vs. So if you able to write the equation directly in the examination hall for the particular type of problem, based on the Doppler effect, then immediately after that you can solve this problem. So problem is not so difficult, but you have to write the formula directly in the examination hall. And the frequency as per the problem, it is n by 2 equal to half of the original frequency, and this is n v by v plus vs, and by simple calculation it is 2v equal to v plus vs. At what speed? Okay, so velocity of source is equal to velocity of sound. So option 4 is the correct option. Next problem. Moment of inertia of magnetic needle is 40 grams centimeter square, has the time period 3 seconds in earth horizontal field having value 3.6 10 to the power minus 5 Weber meter inverse to its magnetic moment. Time period of a magnetic needle in magnetic field. It is the magnetic momentum and the angle is theta. Time period of the oscillation, it is twice pi root over I by mb. I is the moment of inertia, and m is the magnetic moment. So the time period given in this problem, moment of inertia time period is 3 seconds. Let us say this is 3 square, 4 pi square, value of I, moment of inertia 4 into 10 to the power minus 6 by magnetic field 36 into 10 to the power minus 6 into m. So m is equal to 4 pi square by 3 into 4 by 36. Roughly 4 pi square by 3, sorry, by this is not 3, it is actually 9. This is 9, or 9 or pi square roughly can be removed. The value of pi square is near about little bit more than 9, so pi square 9 can be removed in this way, and this is 4 by 36. Finally it is 4 into 4, 16. By 36, and it is 0.5. I have done here the approximate calculation. I am proceeding through approximate calculation because just by observing the 1, 2, 3, 4, all these options are well differentiated here. So this is why I am going through the approximate calculation, and the answer becomes 0.5. Answer becomes 0.5 ampere meter square. Okay, the right option here is 1. Next problem. In an ammeter, 10% of main current is passing through galvanometer if the resistance of the galvanometer is Z, then the shunt resistance is, here we know the shunt required equal to Gn minus 1, where N is the I main current by current through galvanometer. This factor is known as shunt factor. This factor is known as shunt factor, and here the shunt factor, the main current is I and the current through the galvanometer is 10% of the main current, that is I by 10, and shunt factor is 10. Therefore the answer is G. The value of G given here, it is G by 10 minus 1, so therefore the answer is G by 9. Okay, right option is G by 9. So 2 is the right option here. And in this way I have discussed from question number 1 to question number 45, and these small efforts will help you or enhance your strength so that you can apply this approach what I have done in my discussion. That's all for today.